Unit I. Materials. EXPARIMANT1. Aim. To study the different parts of a simple, dissecting microscope. Theory. The human eye cannot distinguish objects smaller than 0.1 mm, hence, we cannot observe cells, tissues, and minute organisms through naked eyes. Before the invention of microscope, biologists used lenses that could magnify minute objects only up to some extent. Subsequently, scientists started using combination of lenses that led to the invention of microscope. Microscopes are instruments designed to produce magnified visuals of smaller objects. The simple microscope, also known as dissecting microscope, has a single lens system through which the image of an object is seen. The simple microscope is in fact a magnifying lens mounted on a metallic frame in such a way that lens can be mechanically moved up and down or sideways to get a magnified view of the object under observation. Its principle is not different from an ordinary lens used by a watch repairer. Materials required. A simple, dissecting microscope, permanent slides of plant or animal materials, parts of plants, or small insects, a slide, forceps, and a needle. 08072014. Laboratory Manual, Science. Description. A simple, dissecting microscope Fig. 1.1 consists of the following parts. 1. Base. It is the basal part that is bifurcated and supports the weight of the microscope. It is generally horseshoe-shaped and is made of metal. 2. Stand. It is a short, hollow cylindrical rod fixed to the base. Another small cylindrical rod called vertical limb fits into the stand. At the other end, the vertical limb can be moved up and down, with the help of an adjustment knob attached to the upper end of the stand. Lens. Folding arm. Vertical limb. Stage. Clip. Adjustment knob. Mirror. Stand. Base. Fig. 1.1. A simple, dissecting microscope 3. Folding arm. To the upper end of vertical limb, a flat horizontal folding arm is attached. This can move sideways. 4. Stage. It is a rectangular glass plate fitted with a pair of clips on its upper surface. The clips are used to hold the object or slide on the stage. 5. Mirror. A movable planar concave mirror is attached to the stand below the stage for reflecting light onto the stage. 6. Lens. A simple convex lens, known as eyepiece, is mounted on the folded arm. The magnification of a dissecting microscope depends on the magnification of the lens, which is normally 5x, 10x or 20x. X denotes the number of times a lens magnifies an object. 1408072014. Materials. Procedure 1. Clean the stage, lens and mirror with a soft and dry cloth or with a tissue paper. 2. Place a permanent slide or a slide with an object mounted on it on the stage. 3. Adjust the mirror to get maximum, reflected, light onto the object. 4. Align the microscope lens over the object under observation. 5. Rotate the adjustment knob to bring the object to clear focus. Precautions. Keep the microscope in its box after use. Clean the lens and mirror with a lens cleaning solution. Always wipe the lens and mirror with a piece of silk cloth. Always carry the microscope in an upright position. Use both your hands to hold it. Clean the stage properly before placing the slide. Take care to prevent the microscope lens coming in contact with the slide or an object. Note for the teacher, a dissecting microscope is used to observe whole mounds of small organisms, parts of plants or animals, and for dissecting small organisms. It is important to acquaint the students with the precautions to be adhered to while handling a microscope before they proceed for using it. It is advised to mount a suitable material on a slide and demonstrate to students. Questions. What is the magnification of the simple microscope you have used? Why is a simple microscope also called a dissecting microscope? Which type of mirror is fitted in the simple microscope? What is its function? 1508072014. Laboratory Manual, Science. EXPARIMANT2. Aim. To study the different parts of a compound microscope. Theory. A compound microscope uses a combination of simple lenses in the objective and the eyepiece. It offers a much higher magnification of an object than the simple microscope. Materials required. A compound microscope and permanent slides. Description. The compound microscope, Fig. 2.1, consists of the following parts. 1. Base. It is the basic part that is bifurcated and supports the weight of the microscope. It is made of a metal. 2. Arm. It is curved and supports the body tube. Knobs for coarse and fine adjustments. Stage and mirror. It is used for holding the microscope. The arm is attached to the base by an inclination joint. 3. Body tube. It is a hollow tube attached to the upper end of the arm. It has the eyepiece at the upper end and a circular, movable metallic ring called nose piece at the lower end. Objective lenses are screwed 1608072014. Materials into the grooves present beneath the nose piece. Usually two objective lenses of 10x, low power, and 40x, high power, magnification are provided. 4. Stage. It is a rectangular platform attached to the lower end of the arm. There is a hole at the center of the stage which allows light from. Eyepiece. Revolving nose piece. Low power objective lens. High power objective lens. Stage. Stage clip. Iris diaphragm. Mirror. Stand. Arm. Coarse adjustment knob. Fine adjustment knob. Fig. 2.1. A compound microscope, the mirror to pass through it and to fall on mounted slide. A pair of clips is provided to hold the slide firmly on the stage. 5. Diaphragm. It is present below the stage and is used for adjusting the intensity of light. 6. Coarse adjustment knob. It is attached to the arm and it moves the body tube up and down for focusing the object. 7. Fine adjustment knob. It is attached to the arm and moves the body tube up and down very slowly. The fine adjustment is very essential for fine focusing of object, particularly in high power. 8. Mirror. A plano concave adjustable mirror is fitted below the stage to reflect light onto the objective. 1708072014. Laboratory Manual, Science. Procedure 1. The microscope should be placed safely on the working table with the arm facing yourself. 2. Clean the eyepiece, objectives, and the mirror with a soft and dry silk cloth. 3. Rotate the nose piece slowly till it clicks in position to bring the low power objective in line with the body tube. 4. Adjust the diaphragm for allowing optimum light to pass onto the stage. 5. Observe through the eyepiece. Tilt and turn the mirror towards the light source and adjust its position till the microscopic field appears bright. 6. Place the slide on the stage and move it so as to view the object on the slide. 7. Move the body tube with the help of coarse adjustment knob until the image of the object is seen. Sharpen the focus with the help of fine adjustment knob. 8. For viewing the object under high power, turn the nose piece to high power objective after the object is focused under low power. Using the fine adjustment knob, focus the object. Precautions. While carrying the microscope, hold its arm with one hand and support the base with the other. See Fig. 2.2. Place the microscope with its arm facing yourself. See Fig. 2.2. B. Do not tilt the microscope. Keep it in upright position. See Fig. 2.2. C. Do not use coarse adjustment when viewing through high power objective. See Fig. 2.2. D. The slide may break. Use a tissue paper or clean silk or muslin cloth for cleaning lenses and mirror. Fig. 2.2. A. Place the microscope gently on the working table about 15 cm away from the edge of the table to prevent its accidental fall. Fig. 2.2. F. Do not allow direct sun rays to strike the mirror. Use plain mirror for natural daylight and concave mirror for artificial light. After use, lower the body tube and keep the microscope in its box. 1808072014. Materials. 2. Toned A. 2B. Toned. 2. Toned C. 2D. Toned. 2. Toned A. Fig. 2.2. Handling of a compound microscope 1908072014. 2F. Toned. Laboratory Manual, Science. Note for the teacher, it is important to acquaint the students with the precautions to be followed for handling a microscope before they proceed to use it. Magnification of lenses is often written on the surface of the objectives and eyepieces. It denotes the number of times the object is magnified. In a compound microscope, generally an eyepiece is 10x or 15x and an objective is 10x and 40x or 45x. The magnification M of a compound microscope is the product of magnification of eyepiece lens and that of objective lens. For example, the magnification of a compound microscope with 10x eyepiece and 40x objective is 10 times 40, that is 400. Questions: what will be the magnification of a microscope when 15x eyepiece and 40x objective are used? Why is it suggested not to reflect the sunlight directly into the body tube of the microscope? What is the difference between a simple, dissecting, and compound microscope? What is the function of an adjustment knob in a microscope? Which of the following parts supports the weight of microscope? A. Arm. B. Stage. C. Body tube. D. Base. Name the part of a microscope with which objective lenses are fitted. A. Nose piece. B. Diaphragm. C. Stage. D. Arm. What holds the slide firmly on the stage of a microscope? A. Diaphragm. B. Clips. C. Nose piece. D. Objective. Which of the following regulates the intensity of illumination in a compound microscope? A. Diaphragm. B. Body tube. C. Stage. D. Mirror. 2008072014. Materials. EXPARIMANT3. Aim. To determine the density of a liquid, other than water, by using a spring balance in a measuring cylinder. Theory. The density, ρ, of a given substance is the mass of its unit volume. For a substance of mass m and volume v, the density is given by the ratio m. V ρ equals. In this experiment, the density of a liquid will be determined by finding the mass of its known volume. Materials required. A spring balance, 500 grams, measuring cylinder, 100 milliliters, polythene bag according to the size of the measuring cylinder, and the given liquid, kerosene, turpentine oil or any other. Procedure 1. Find the range and least count of the spring balance in the measuring cylinder. Hint: to determine the least count of a spring balance or a 2108072014. Laboratory Manual, Science Measuring Cylinder. Note the value of the physical quantity measured by it between any of its two adjacent numerically marked divisions. Dividing this value by the number of smaller divisions between them gives the least count of the device. 2. Hold the spring balance vertically and ensure that its pointer is at 0 mark. Place the empty cylinder in a polythene bag and suspend it from the spring balance as shown in Fig. 3.1. Note the reading, M1 of spring balance. 3. Place the measuring cylinder on a horizontal surface like a table. Pour the given liquid, whose density is to be determined, in the measuring cylinder. Note the volume, V, of the liquid, Fig. 3.2. 4. Put the liquid-filled cylinder in the polythene bag and again suspend it from the spring balance. Note the reading, M2, of the spring balance. Fig. 3.1. Measurement of mass of a measuring cylinder using a spring balance. Fig. 3.2. Measurement of volume of given liquid. Observations: I. Range of the spring balance. E. Least count of the spring balance. E. Range of the measuring cylinder. IV. Least count of the measuring cylinder. 2208072014 equals blank G equals blank G equals blank milliliter equals blank milliliter. Materials: V. Mass M of the given liquid. I. Mass of the empty cylinder in the polythene bag. M1 E. Mass of the liquid filled cylinder in the bag. M2 E. Mass of the liquid. M equals M2 M1 V. Volume of the given liquid V. Calculations: volume of the given liquid V. Mass of the given liquid M. Density of the liquid ρ equals M. V equals blank G equals blank G equals blank G equals blank milliliter equals blank milliliter equals blank G equals blank G per milliliter equals blank kilogram M3 1 kilogram per cubic meter equals 0.001 grams per milliliter. Results and discussion. The density of the given liquid is blank kilogram per cubic meter. Find the standard value of density of the given liquid and compare it with the observed result. See Appendix, circa. Precautions. The measuring cylinder must be clean and dry. The measuring cylinder should be placed on a horizontal surface while measuring volume of the given liquid. While observing the liquid meniscus, the line of sight should be at the same horizontal level as that of the lowest meniscus. There should be no air bubble in the liquid while measuring its volume. The spring balance should be held vertical while taking measurement. Before making use of spring balance, it must be ensured that its pointer is at the zero mark. The readings of the spring balance should be noted only when its pointer comes to rest. Sources of error. The graduations marked on the measuring cylinder and on spring balance may not be evenly spaced. A spring balance is primarily meant for measuring the weight, force, of a body. However, in laboratories, a spring balance is often used to measure the mass of a body. It should be remembered that the 2308072014 Laboratory Manual. Science calibration of spring balance scale is done at the place of its manufacture and depends on the value of acceleration due to gravity, g, at that place. Therefore, if a spring balance is used to measure mass at any other place where the value of g is different, an error in the measurement of mass will appear. Questions. A spring balance calibrated in Newton reads 19.6 N. What will be its mass in grams at your place? You are given two measuring cylinders of least count 1.0 milliliters and 2.5 milliliters, respectively. Which one will you prefer to determine the density more accurately? Write 2 precautions that you will observe while measuring the volume of a liquid with the help of a measuring cylinder. 2 bottles of equal volume are filled with glycerine and water respectively. Which of the bottle will be heavier? Give reason for your answer. Why is the density of water at 80 degrees C less than its density at 30 C? 2408072014. Materials. EXPARIMANT4. Aim. To determine the density of a non-porous solid, and soluble and denser than water, by using a spring balance in a measuring cylinder. Theory. The density, ρ, of a given substance is the mass of its unit volume. For a substance of mass m and volume v, the density is given by the ratio, ρ equals. Materials required. A spring balance, 0-500 grams, measuring cylinder, 100 or 200 milliliters, a piece of thread, water, and a small piece of experimental solid. Procedure 1. Find the range and least count of the spring balance in the measuring cylinder, explained in experiment 3. 2. For finding the mass of the given solid, suspend it from the spring balance with the help of thread fig. 4.1. Note the reading of the spring balance. 2508072014. M. B. Laboratory Manual. Science 3. Place the measuring cylinder on a horizontal surface like a tabletop and fill it with water, say, up to the half of its range. Note the reading of the water meniscus as the initial volume. 4. Tie the given solid with a thread and lower it slowly in water in the measuring cylinder. What happens to the level of water in the cylinder? Let the solid to immerse completely in the water. Next, note the reading of water meniscus as the final volume, Fig. 4.2. Fig. 4.1. Measuring of mass of solid using spring balance. Fig. 4.2. Determination of volume of a non-porous solid. 5. Take out the solid from the measuring cylinder. Dry it and repeat the activity by taking different initial volume of water in the cylinder. In each case, note the initial and final readings of water meniscus. Observations and calculations. I. Range of spring balance. E. Least count of the spring balance. E. Range of the measuring cylinder. IV. Least count of the measuring cylinder. V. Mass, m, of the given solid. V. Volume, V, of the given solid equals, blank, G equals, blank, G equals, blank, milliliter equals, blank, milliliter equals, blank, G. SL. Initial reading. No of water meniscus. V1 milliliter 1, 2, 3, 4, 26, 08, 07, 2014. Final reading water meniscus. V2 milliliters. Volume of solid mean value. V equals V2 V1 milliliter of volume of solids. V milliliter. Materials. Density of the solid rho equals M. V equals blank G per milliliter equals blank kilogram M3 1 kilogram per cubic meter equals 0.001 grams per milliliter. Results and discussion. The density rho of the given solid is blank kilogram per cubic meter. Find the standard value of density of the given solid and compare it with the observed result. See Appendix B. Precautions. The measuring cylinder must be dry and clean. The measuring cylinder should be placed on a horizontal surface while reading the water meniscus. While observing the liquid meniscus, the line of sight should be at the same horizontal level as that of the lowest meniscus. There should be no air bubble in the liquid while measuring its volume. The spring balance should be held vertical while taking measurement. Before making use of spring balance, it must be ensured that its pointer is at the zero mark. The readings of the spring balance should be noted only when its pointer comes to rest. The solid piece should be wiped with a dry cloth before repeating the activity. Sources of error. The graduations marked on the measuring cylinder and on spring balance may not be uniform and evenly spaced. A spring balance is primarily meant for measuring the weight, force, of an object. However, in laboratories, a spring balance is often used to measure the mass of an object. It should be remembered that the calibration of spring balance scale is done at the place of its manufacture and depends on the value of acceleration due to gravity, g, at that place. Therefore, if a spring balance is used to measure mass at any other place where the value of g is different, an error in the measurement of mass will appear. 2708072014. Laboratory Manual, Science. Note for the teacher, the method described above is useful for small solid objects. In case of larger objects, one should make use of an overflow can rather than measuring cylinder. This method is only useful for non-porous and water-insoluble solid objects. Therefore, it is advised to use a metallic solid. Some error in the measurement of volume of the solid piece may occur even if it has meager porosity. The density of solid should be more than the density of water so that the solid can sink in water. If the density of solid is less than the density of water, then a sinker can be used to perform the experiment. Earlier experiment titled, to determine the density of a liquid, other than water, by using a spring balance in a measuring cylinder, also uses a spring balance. It is therefore advised that students may perform the earlier experiment first to be aware of the instruments used in this experiment. Questions. Can you determine the density of a porous solid by using a spring balance in a measuring cylinder? Give reasons in support of your answer. How the presence of an air bubble in the liquid taken in the measuring cylinder can affect the volume of the solid. Density of sealing wax is 1.8 grams per cc. Express it in kilogram per cubic meter. A metal cylinder is melted and the whole mass is cast in the shape of a cube. What happens to its density? Give reasons. At which temperature is the density of water maximum? 2808072014. Materials. EXPA